Okay, this problem is kind of difficult because you have to make a few mental leaps here. But it reads, the white blood cell concentration in normal blood is approximately 12,000 cells per millimeter cubed of blood. So what I've done is I've written right down here my given information, 1.2 times 10 to the 4th cells per millimeter cubed. How many white blood cells? That means this is what I want. I want to know how many cells over 1 would be present in 12 liters of blood. Make sure you put your answer in scientific notation and correct significant figures. So when I start to set this up, I'm going to work backwards because it looks like a pretty complex problem to me. I'm going to want to end with however many cells over 1. So when I look in my toolbox here, I've got this term, and I can put cells on top. So I've got 1.2 times 10 to the 4th cells over a millimeter cubed. Now this is where it gets a little bit fuzzy for me because I don't have anything that says millimeter cubed. Where'd that come from? So I got to rethink some things. A millimeter is length. Now we've been using in class the fact that a centimeter cubed is a measure of volume and it's equal to a milliliter. Okay, so I know that 1 milliliter equals a centimeter cubed. In medical terms, for some reason, they'll say cc or centimeter cubed, I guess is what cc stands for. But in science, we'd either say a centimeter cubed or a milliliter. But still, I don't have a millimeter cubed. So what I have to do is I have to turn this unit of length, which is a millimeter, into a unit of volume by cubing it. So if I can turn a millimeter into a centimeter and then cube it, I've got something I can work with. So I can see that there are 10 millimeters in every centimeter. Now, I want centimeter cubed and I want millimeter cubed. So if I cube one side, I have to cube the other one. So when you cube a 10, you get 1,000, or 10 cubed. When you cube the unit millimeter, you get a millimeter cubed. When you cube 1, you get 1. When you cube centimeter, you get centimeter cubed. So now I've got something that I can put into my toolbox that might help me out. So if I look at my new toolbox, I've got these new numbers added here. That there's 1,000 millimeter cubed in a centimeter cubed. Or I can even use it more effectively if instead of calling it a centimeter cubed, I call it a milliliter. So there's 1,000 millimeters cubed in a milliliter. Okay, now I'm also dealing with this unit 12 liters here. So I also have to know that there's 1,000 milliliters in a liter. So let me reset up my problem. I want to end up with cells. And I already established that I can use this term because it has cells on top. And this is where we left off. So we had 1.2 times 10 to the 4th cells on top and millimeters cubed on the bottom. So now I got to get rid of millimeters cubed. So I come up here and I see this term has millimeter cubed in it. So I'm going to leave it so that millimeter cubed stays on top. And that allows me to cancel millimeter cubed and leave cell. But now I've got the problem with milliliters being down here. So I can come up and grab this term, bring it on down, so that my milliliters cancel, and I'm still left with liters. So I can come up here and grab this one and put that over 1. So now my liters cancel, my milliliters cancel, my millimeter cubed cancels, and I'm left with only cells. Now when I multiply all these together, I've got 12 times 1,000 times 1,000 times 1.2 times 10 to the 4th. And that gives me 1.44 times 10 to the 11th cells. Now, my original numbers had 2 significant figures. So that means that I can keep two significant figures. So I would round this off to say 1.4 times 10 to the 11th cells.